Welcome to solverfy.
In this question, there's a ladder that's making an angle that's placed against a wall and then making an angle 30 degrees from above the floor, horizontal floor. And then at this instant, point B at the top of the ladder is moving down with 4 feet per second and acceleration 2 feet per second downward, per second square downward. Okay, and we need to determine the acceleration of point A and the ladder's angular acceleration at this instant. Okay, so we note that VA is to the left. Okay, so likewise, the acceleration of point A will also be to the left. Okay, so we can actually determine the instantaneous center of zero velocity, which will be somewhere here. Okay, this is the IC. Okay, so we want this distance, which is 16 cosine 30 degrees. Okay, we can use this distance to determine omega of AB. Okay, so omega AB is VB divided by RIC to B. Okay, so this is 4 divided by 16 cosine 30 degrees. Okay, again, it's going to move clockwise. So this is going to be 1 over 2 root 3. Okay, this is equal to 0.289 radians per second. Okay, then we can use the relative acceleration equation. AA is AB plus alpha AB cross RB relative to A minus omega AB square RB relative to A. Okay, so AB is so this is minus AA in the I direction. AB is minus 2J. Alpha AB is minus alpha AB K cross RB relative to A will be minus 16 cosine 30 degrees I plus sine 30 degrees J. Okay, so actually both are negative, just that I put the negative sign out. Okay, and then I have a plus 1 over 2 root 3 square times 16 cosine 30 degrees I plus sine 30 degrees J. Okay, so the negative 16 cancels the negative sign, so it gets a plus. Okay, so the negative sign becomes a plus. The cosine 30 degrees is square root 3 over 2. Sine 30 degrees is half, so I take out the half. So 16 divided times half becomes 8. 8 alpha AB, and then we have K cross I, we get J, and then we have a minus I with K cross J. Okay, and then plus 1 over 12, 16, 1 over 2 root 3I plus J. Okay, so just continue. Okay, so this is 3, 4, 2, 1. Okay, so minus 2 j plus 8 alpha AB minus I plus j plus 2/3 root 3I plus j. Okay, group the terms like term together. It's minus 8 alpha AB plus 2/3 root 3 I plus minus 2 plus 8 alpha AB plus 2/3 root 3 2/3, sorry, just 2/3 j. Okay, now we are ready to compare components. So again, we do the y component first because we can get the alpha AB straight away. Okay, so alpha AB is 1/8, 2 minus 2/3. Okay, so you get 0. Okay, made a mistake somewhere. So okay, so I missed a root 3 somewhere. Okay, so yeah, so here there is a root 3. Okay, yeah, there's a root 3. Okay, just to rewrite. Okay, sometimes it's so easy to make mistakes. Okay, right, so yeah, there is a root 3 over here. Sorry about that. Okay, so 1/8 root 3. Just to rewrite. Okay, 1/8 root 3, 2 minus 2/3 times 2 minus 2/3. So this you get 0.0962 radians per second square. So just remember that this is clockwise. And then if we do the x component, then we can get our acceleration of point A. This is 8 alpha AB minus 2/3 root 3, and you put in the numbers, you get 0.385, then with a negative sign. Okay. Yeah, negative 0.385. Yeah, so it turns out that the acceleration of point A is to the right. Okay. Yeah, so like because we set a I set a so a the acceleration of point A is 0.385 I feet per second square. Okay, so this is the acceleration of point A, and then this is the angular acceleration of the length of the ladder AB. Okay, and that's all.